In this video, we learn about georeferencing images, or the assigning of coordinates to maps or aerial photos. There are many online data warehouses to download these images from. I've provided links to some well-known ones with maps for the US and world. We will discuss three primary ways of georeferencing these images. The first uses coordinates from the map itself. This is useful if you have a map that lists a coordinate system, but otherwise may be difficult to relate to present features. Next, we'll georeference an aerial image and relate points on the image to modern locations. So this is a historical aerial image. And finally, we'll use the Public Land Survey System, or PLSS, to georeference a map. The PLSS is specific to the US, and even then not in use everywhere. For those states that use the PLSS, this is very helpful in georeferencing maps. The lesson concludes with a quick introduction to digitizing features from maps. As always, timestamps are available in the description so you can jump from section to section. Okay, let's get started. So the first map that we'll georeference will actually use coordinates that are embedded in that map. And of course, remember, if you're still at QGIS 3.2 or anything really before 3.14, we're going to have to make sure that we have that plugin installed. So if we open that up and look for our Georeferencer GDAL plugin, we can see I have it installed. If you don't, make sure to install that. The reason I say 3.12 or below, at 3.14 this plugin becomes standard. It's already activated. So let's go ahead and go up to Raster, Georeferencer, and this is actually how we're going to add a map or image and georeference it in QGIS. Go ahead and click this button to add our raster or image, and we'll actually be georeferencing, in this first case, a map of the Davy Crockett National Forest in Texas. So double click to add that, and then you can press your middle mouse button to sort of pan around and scroll in and out to get accustomed to this map. And we can see here that we have our degrees, minutes, and seconds, in other words, our coordinates, listed on this map. And you can also follow these to these little hash marks that denote an intersection between marked coordinates on the edges of the map. But before we start recording any of those or listing those or creating what we call ground control points, in other words, assigning points in this map real world coordinates, we need to find out what coordinate reference system this map is using. Now, this is going to happen from time to time. What I've done here is, while trying to scroll, I've accidentally clicked the left-hand button on my mouse and it's trying to enter a coordinate. Just go ahead and click cancel. We don't want to do that accidentally. As I said, we want to try to find our coordinate system. In this case, we can see it's the North American datum 1927. That means it's a geographic coordinate system. And so we'll come up to settings and transformation settings, and we want to set that in the target spatial reference system. So you can go ahead and open this and click NAD 27. And since we know there's no remarks on the map about this being a projected coordinate system, we know it's a geographic coordinate system, and go ahead and select that and click OK. That's going to be pretty common on these older maps. I go ahead and use thin plate spline and leave this at nearest neighbor. There are different settings for this, and you can explore those, and I'll include a link that gives you more information about those. As you'll see here, the output raster is just going to append an underscore modified to the name, and it's going to put it in the same directory. So we're good now to click OK and start adding those ground control points. Let's go ahead and go up to the left hand or northwest corner of this map and find that first hash mark that we identified at the beginning of this. Here it is. So we want to go ahead and just click once, get our little cursor right in the middle there, click, and this is going to bring up our dialog to enter map coordinates. So let's go ahead and enter the north coordinate first. We can see it here. This is 31 degrees, 30 minutes, and there's nothing listed for seconds, so we know that's 0. Now we also need to come up here and list the east. We can see this is 20 minutes, but there's no degree listed here. So we want to scroll back, and we see that this is negative 95 degrees, 20 minutes, and 0 seconds. And you'll need to put the negative here because we're in the western hemisphere. Go ahead and click OK. Make sure there is a negative here in that destination X. These destination X and Y, these are your coordinates that you're assigning to these ground control points. So we've already added one. go ahead and come over here towards the right hand side and see if we can't find another hash mark here. I like this one. It's actually sort of overlapping the legend, but that's okay. Click on that and we can scroll out again to try to find these coordinates. So let's go ahead and do the northing first. So this is 31 degrees, 30 minutes, and 0 seconds. Let's do the easting. So this is going to be the first one away from the corner up here. We can see this is just below 95. So we're going to do a negative 94, 50, 0, 0. And you can sort of see that as we move west, these numbers are going up. So that's how we know to go down 1 degree before we enter the minutes. Click OK, and we've now added 2 of our control points. And we can see actually that 2 of them match exactly. And that makes sense because those Y coordinates are our northing, and the northing here at the exact same degree position. Let's go ahead and come back down to the south and try to find some coordinates here to enter. We have a really nice hash mark right here in the lower right hand corner. So let's click on that and add those coordinates. Go ahead and do the northing first because it's right here. So this is 31, 0, 0, 0, 0. The easting is actually going to be the same one we just entered. So negative 94, 50, 0, 0. Click OK. And now we need to go ahead and try to find one in the lower corner over here. There's a nice one here that we'll go ahead and add. Scroll out to get the number here. Let's go ahead and go with easting first. We're going to be at negative 95 degrees, 10 minutes, and 0 seconds. And then, of course, we need to find the northing. Move this out of the way. So the northing here is going to be 31 degrees, 0 minutes, and 0 seconds. Click OK. So we now have some very nice lined up points. I'm going to go ahead and add at least one more, and I think right out here is going to be a nice one. So we have a good distribution of these points. Let's go ahead and enter the northing first. So we can see this is going to be 31 degrees, 10 minutes, and 0 seconds. 31, 10. And of course we need our easting, which is going to be down here, 20, but we know that that's actually negative 95. Negative 95, 20 minutes, and 0 seconds. So click OK. Now we have 5 good points here. We could add one in the middle. You could add many more points. You could hunt out all of those hash marks and add a point to all of them. The more ground control points you add, the better your georeferencing is going to be. But that's good enough for now, so let's go ahead and transform this, or go ahead and start the georeferencing process. What this will do is bring up our progress indicator, and once that's finished, we can add the map to QGIS. Okay, that's complete. We can go ahead and close the Georeferencer dialog or window here, and then we can navigate to the file that was just created. And as you'll see here, we can see we have one that has the underscore modified added to it. So we double click to add that to the map. It'll ask us to do a quick transform. That's fine. This looks pretty good. Let's go ahead and add a base map and see if it lines up. So if we turn this on and off, we can see that that lines up perfectly. We can actually come up here and even reduce the opacity, and we can see how well this is lining up. And it may not be perfect. This is a pretty large map, right? It has a small scale, meaning it covers a large area, so there will be some discrepancies in here. Also, if any of them are very large, or the map looks skewed or anything else, it likely means you've gotten some of those control points incorrect, and you can go back through and basically repeat the entire georeferencing process to update that. But this looks good, so that we will consider a success for georeferencing a map using the coordinates within the map itself. Next, we'll go ahead and georeference a historic aerial image. Now, of course, these don't have any sort of coordinate system embedded in them, so we're going to have to kind of play a game of matching what was there with what is there. And so the historical aerial that we'll be using for this is actually of Logan, Utah from 1937. So you can start with the aerial begin QGIS document, and this will get you into the correct area. And we can sort of see here we already have a Google satellite image of this area. We can expect a lot of change and development has taken place in this area since 1937, so approximately 80 years ago. We'll start by starting the Georeferencer and then adding that raster. So Logan, Utah, 1937. And again, we can navigate here with our middle mouse button by either pressing or scrolling. And like I said, this is going to be something of a hunt to find features in the current view that match the historic view. We can already find one here. This curve in this row continues until today. We can see some of these other features. So this intersection here, perhaps this one is even better, is something that persists on both the historic and modern aerials. So let's go ahead and add a ground control point at this intersection. And intersections are good things to use because the center points of them don't change that much. So of course what I've just done is I've clicked once to bring up that dialog, and then I've used from map canvas to assign a coordinate system to it. And what we'll need to do now is basically hunt around here and find other features in the area that match between the 1937 aerial and today. And this is something that is funky. You may see it happen here as well. As I scroll out, these points get a little messed up. That's going to correct itself once we actually georeference this map, but it could look like something is messing up, but it'll shake out and be correct in the end. So let's go ahead and move over to this part of the map, and we can actually see here this curve may at first appear to match this curve, but if you scroll back and you see this other road coming off here, this curve in 1937 was the end of the road and corresponds actually to this intersection. So don't let this confuse you. We're going to actually add a control point here first, and then of course add a control point from that same intersection on the map canvas. Click OK, and we've now added our first two control points. So go ahead, I'm going to go ahead and pause the video here and add a few more control points. One of the easiest ways, particularly in these areas with gridded streets, is to count blocks and find intersections that correspond between the historic and the modern aerial. So I'll be right back. Okay, so we've gone ahead and added here several control points, 8 in this case. So what we'll want to do is click the Start Georeferencing, but because we haven't set a coordinate system for this yet, we'll need to go ahead and do that. So we'll want this coordinate system to actually map whatever coordinate system we're using in the main map document. And in this case, that's Google coordinate system, or the coordinate system associated with Google Maps. So what we'll want to be using is the WGS84 pseudo Mercator. So click OK. We see that this is going to automatically append _ modified to the image. We're going to save ground control points. Click OK. Click that Start Georeferencing button again, and it will start georeferencing it. Now that the georeferencing is finished, we can go ahead and exit out of this and add that aerial to our main map document. As we click Close, it'll automatically save those ground control points, and we can see here our new document created. So when we add that, we can see actually that that looks like it's lining up pretty well. If we turn it on and off, we can see that this is doing a pretty good job. We can scroll in a little bit closer and have a better look, but we're seeing all of the sort of overlaps we hope to see. And we can actually see that some of these buildings have survived, but most of this area is showing completely new things having developed. So that's it. A little trick here. If you don't like this black border, let's go ahead and bring the opacity all the way back up. Click this plus size under the custom transparency options, and the red, green, and blue will automatically be set to 0, which means anything that is a solid black is going to be removed. And so you've now gotten rid of that black. Of course, anything else in the image that is a solid black will also be removed. You can also do this with the absolute white values. That'll remove a lot of that other border, but of course anything else in here that's pure white will also be removed. But we can see here at the edges now, this is lined up really well. So this would be a great document to sort of look at, in this case in Logan, Utah, 80 years of changes to the environment between these two maps. Our final georeferencing task will be to assign points to a map where there are perhaps coordinates, but other reference systems in place. And take a moment and talk about the Public Land Survey System, and we can see that it corresponds or is present in the vast majority of American states, but not all of them. And so in the areas where you don't have the Public Land Survey System, the methods we're about to talk about obviously won't work. But in the areas where we do, the Public Land Survey System is basically broken down into overlapping geometries. Townships and ranges basically determine the easting and northing position of a 6 by 6 mile rectangle. And this 6 by 6 mile rectangle is then broken into 36 1 mile square or 1 mile by 1 mile square rectangles as well. And so you can see here 1, 2, 3, it's numbered sort of in a back and forth way. And so every section and township, so for instance, as we'll see, we'll have maybe north 1 and east 3. So that's a 36 square mile area, and within that we'll have 1 square mile areas, and those 1 square mile areas are the sections. So when you hear people say section, township, and range, and property descriptions and so forth, they're talking actually about the Public Land Survey System, and that's what we're going to use now to georeference a map. And we're going to add our St. Francis National Forest raster. And here, if we scroll around and look, we can see the town of Mariana, which is also here. We've just got a Google Street Map on underneath our PLSS grid. All of this data is of course available in the project data download folder, including a PLSS begin map document, which would take you immediately to the right area. So if we look at these township and range numbers, we can see that these actually match numbers in the map. So township 2 north, 2 north, 2 north, 1 north, 2 north, 3 north, sort of moving up, and then range 3 east. We know in this area we're dealing with grid in this part of the map. So what we can do is go ahead here and turn on our Arkansas PLSS sections, and we can see these small numbers in red are corresponding to these small numbers here. And so we have nice intersecting points where we can assign coordinates to this map. So here we have our section 24 and section 19. And so what we can do is move up here, add a coordinate, and then of course we're going to be adding one from the map canvas. And this is the north intersection of 24 and 19. And if we don't have snapping on, we can turn that on so that we can snap directly to that intersection. And click OK. And now of course we can move around and basically reproduce this process across the map. So I'll go ahead and pause the video, add these points, and then we'll come back to wrap it up. Okay, we've now finished adding, in this case, 6 control points. We'll need to go ahead and we can either choose the settings drop down and choose transformation settings, or we'll be warned to go ahead and add that. And again, we're using Google Maps as our base map, so we're going to want to make sure that our target spatial reference system or coordinate system is set to that as well. Everything else will still be okay, so we can click OK. We click that button one more time to start the georeferencing, and once that's finished, we'll be able to add that newly georeferenced map. Okay, that's complete. Now we can add this to our main map document. Click that to close and navigate to the St. Francis directory, and we can see our modified image here. So if we double click, this will be added, and we can see that lines up very well. We can turn off these other PLSS layers. I'm going to shift the Arkansas boundary above that so we can see, but when we scroll in here and we can turn this on and off, we can see this lines up pretty well. And what's interesting, it looks like the forest boundaries have actually grown since this map was created, which is great for the forest. Of course, we can always come over, shift the opacity down. If we wanted to turn one of those, the township layer or the section layer back on, we can see not always perfect, and that's because these layers sometimes shift as well. But generally speaking, this overlaps really well. We can see a lot has actually changed out in this area over the last few decades, but a lot has remained the same as well. So that's how we use the public land survey system to georeference these old historic, and in this case topographic maps. So the final section for this lesson is digitizing things from these georeferenced images. So in this, we're going to assume that we want to georeference part of this historic railroad. So the steps for doing this basically involve creating a new layer, a new shapefile layer, and we can save that wherever we need to. I'm going to go ahead and just save it into the vector folder in the download, the data download that you have for this lesson. I'm just going to call it railroad, and we want it to be a line. We can change the coordinate system to whatever we think might work. We know that we're working in this sort of Google Earth WGS84 pseudo-Mercator coordinate reference system, so we'll go ahead and stick with that. We could, of course, add a field here. Maybe I want to know what this is. It's a description, so I could add this, and that means that as I finish digitizing this, I can add a descriptor into the attribute table of this file. So click OK. It's now added. We can click on this layer in QGIS and start editing. And basically, we're going to start adding our line feature. So we can scroll in a bit here, and I'm going to start the intersection here and just quickly start clicking the left-hand mouse button along this line to basically digitize or add this feature into a shapefile. And I'm not going to go the whole way. I'm just going to illustrate this process. So let me pause the video and come back when I've digitized a lot more of this railroad. Okay, so I've finished digitizing this railroad, and when I press the right-hand mouse button, that's going to finish or stop the digitizing process. I can enter in here, I'm just going to say railroad, but if I knew the name or whatever, which is of course listed on this map, I could enter that. Click OK, and if I go ahead and turn off this map, we can see that the railroad was actually digitized on Google Maps. It may or may not be correct. Our map might be a little off, Google Maps might be a little off, or a little of both. But to save this, of course, we want to go ahead and click Save Layer Edits and then stop editing. We can go ahead and turn the Google Road layer off, and we can see our digitized railroad here sort of floating in space. And of course, we could symbolize that in different ways and so forth. So that's how you would digitize your features from all of these georeference maps. They could be polygons, or points, or lines. Just remember to make sure when you add that new shapefile, you select the right geometry type. So as always, links to location of data are in the description. Make sure to hit that like button and subscribe to get future updates. Until next time, keep mapping the past.